And it's pretty simple. It says pressure is a state function. And before I answer this, let me tell you what remind you what a state function is. A state function is a function in which, or a state function is when you change it. No, we stumble on this part. So um, the path from initial to final states is and I'm recording this too. So the initial and final values are independent of the path. The initial and final values of the function are independent of the path. And the example I gave in the lecture outlines was altitude or height. So example, altitude or height. And my example right now is going to be height of this pen. If this pen goes from here to the table, there is a potential energy associated with it, or there's a height associated with that. And if I change it and let it go straight down, the height is still the same from here to the table. And if I move it like this, the height is still the same from the pen to the table. So that's the path. My path is changing. It can go straight down. It can go zigzaggy back and forth. And height is the same, meaning that I can measure it with a tape measure down to the table and it will be the same. Anyway, it's kind of an abstract concept, but what it means to be a state function is that we can use it in chemistry. So anything we use in chemistry is a state function with two notable exceptions. So now let me put it back to my page. Not state functions. Work, which is W, and heat, which is lowercase q. That's a lowercase q with a little curly there. Basically, everything else in chemistry is a state function. Just to list some of them: pressure, volume, temperature. What we're about to talk about is delta H, which is the change in enthalpy, also a state function. And so anything we deal with in chemistry on a regular basis is a state function. The one thing that's different is work, and we'll actually calculate work and we'll show that it is different. That's coming up in some of the problems. And if you've ever driven a car, you know that it takes different amounts of gasoline to go the same distance, depending upon what car you're in. So, example of work. So, and the example of work, depending on the path, well, so if I'm going to do depending upon the path, then it has to be the same car taking different paths. And so, for example, if I drive from my house to Washington, D.C., let's say to the Washington Monument, I can go directly there. or I can go through North Carolina. And the amount of work to get from, or my distance from my house to Washington Monument, the distance will be the same. So distance is a state function, but the amount of work it takes for me or my car will be different. I guess I could also do, I could walk there, which would take one amount of work, and then I could walk down to North Carolina and then to the Washington Monument. Anyway, work is not a state function. It is related to car engines as well, but that's not a good example for what we're doing now. Now, to answer the function, to answer the question, true, pressure is a state function. The only things that are not are work and heat.